Hello everyone, this is a course project of wireless communication, and the topic is research on orthogonal frequency division multiplexing. Multi-carrier modulation takes a key role in 4G system. Multi-carrier transmitting data by splitting it into several components and sending these components over separate carriers signals. In this way, inter-symbol interference can be reduced. When using wireless communication to transmit signals, we always get echoes, especially when we want to transmit large amount of message in a short time. This will cause high bit error rate. The advantage of multiple carrier is that it allows us to transmit as much information as we want in a very short time without ISI. The key point of multiple carrier is, for each channel, the data rate transmitted is very low, so that there are no echoes in these channels. Channels have memory. However, if the data rate transmitted is low, when the transmit ended, the echo has died out. In this case, the channel memory is shorter than symbol duration. In multi-carrier system, instead transmit large amount of data using one channel. One stream is split into multiple streams. Each stream has long symbol duration. Because one stream can be split into thousands of substreams, each substream has very low bit rate. If one substream has been split into, for example, 4,000 substreams, the total speed of transmit can still be high, with low bitrate of each substream. However, each substream needs a carrier. For multiple stream, we need multiple carriers to module each substream and combine them together to complete transmit. Different substream may use different kind of modulation method because channels need different channel quality. In reality, some channels may be used to transmit data, while others are used for training purpose. OFDM is a special case of multiple carrier modulation. In multiple carrier modulation, there are frequency space between carriers. OFDM has minimum frequency spacing. This is also the minimum spacing required by Nyquist sampling rate. According to Nyquist sampling theory, the minimum sampling rate should be greater or equal than twice of the original frequency. OFDM achieve this boundary. In OFDM, we first use QAM or other modulation method. Then the data is split into n substreams. Then the inverse fast Fourier transform is used to get time domain information. Before transmitted, some cycle prefix needed to be added to signal. The reason is that channels has memory. This cycle prefix is used by channels to forget the last transmit. The cycle prefix provided some buffer time so that the channels can clear their memory. In OFDM system, signals are put together. Messages are coupled like a chain. then put into one container. So receivers cannot take just one carrier out. It have to get all the message to get the target one. So each channel is for different user, but any user have to overhear others' message before he get his message because it is shared. In OFDM, all message is a whole package. No one can merely demodulation his message. In this way, the OFDM system double the capacity but brings some inconvenience for users. On the other hand, in FDM, you can just pick your package and demodulate it. Thus, to send same amount of message. OFDM just need B bandwidth, while FDM needs 2B. The limitation of modulation is that it requires very precisely carrier frequency synchronization and time synchronization. If there are if there are carrier frequency offset and time jitter in receive side, it will cause inter-subcarrier interference. At receiver side, there is a carrier recovery and a timing recovery. If the recovery is not perfectly synchronized with sender, it will cause bit error. Though the offset between the receiver side and the sender side is small, even just 3%, it will cause big problem. In this way, the system cannot work. This is why sometimes the digital TV, which all use OFDM, is nothing. This time the bit error rate is very high. In receiver side, system needs to recover the carrier and recover the time, the clock. So first demodulation the carrier, then do the analog to digital convert, and use fast Fourier transform. Then the system get the output and make decision. Besides, when the system makes a decision, it needs to estimate the channel. And there are the received picture when using QPSK modulation method. And the signal to noise ratio is 5 dB, 10 dB, and 20 dB separately. This one is 10 dB SR. This one is 20 dB, and this one is 5 dB. You can see that when the ISR is 5 dB, the picture is quite blurred, and when the ISR is 20 dB, the picture is clear. Then there are the phase error distribution. This one is 5 dB. No, I think this one is 20 dB. SNR. This one is 5 dB. This one is 10 dB. Now let me show you the demo. First, we need to set some parameters. If we input the source file, the IFT size, the number of carriers, and choose a modulation method. This time we use QPSK. And multifocal bin is random choose 10 and SNR. First we try 5 dB. We can see that the picture is blurred. Now we try other parameters. Again, input some parameters. We keep other parameters unchanged. This time the signal to noise ratio we set it to 20. You can see that this time the received picture is more clear. Okay, that's all. Thank you for your watching.